Water is pretty amazing if you think about it on a large scale. About 2/3 of the planet's covered with oceans that are connected and teeming with their own amazing ecosystems. And if you think about it on a smaller scale, more than half of our own body's mass is water. Some of it's just hanging out, lubricating your knees and your elbows, or protecting your brain, acting like a shock absorber. The water in our body serves as a place for chemical reactions to constantly be happening. Water brings nutrients and oxygens into our cells. All through your body, you have chemicals, ions in the fluids in your body, ions like sodium chloride and potassium that help send electrical signals through the nerves. Sodium chloride, or table salt, is a compound that's formed by sodium transferring its valence electron to chlorine. And sodium, when it loses its valence electron, forms a positively charged cation. And chlorine, when it gains that electron, forms a negatively charged anion. And that attraction between the chloride and sodium atoms is pretty strong, and it forms a nice stable crystalline structure like you see here. And that makes sodium chloride a fairly brittle compound, and it gives it a high boiling point and a high melting point. But as soon as you put that sodium chloride crystal into water, because it's so polar, pretty easily pulls that structure right apart. So water's polarity, remember that the oxygen end of the water molecule has a partial negative charge, and the hydrogen end has a partial positive charge. So that hydrogen end is going to be attracted to the negative chloride anion, and the oxygen end, the negative oxygen end, is going to be attracted to the positively charged sodium ion. And in fact, water will form a shell around the ions, just as you see depicted here, and keeping those ions apart or dissociated. So back on the first slide, one of the functions of water in the body was to transmit electrical impulses. And so electrical impulses, electricity by definition is a form of energy that results from the existence of charged particles. So charged particles, we know in chemistry, are ions. So if you have ions in water, or charged particles in solution, ions in solution, they'll allow that solution to conduct electricity. So in these diagrams, we're taking a look at how we would be able to light a light bulb by having the light bulb, the electricity conducted through the water. So in this particular diagram, we would have in this beaker of water attached to that light bulb, we would have a positive pole and a negative pole. Now, if you just stuck this into plain water with nothing in it, there's not going to be anything to bring in contact the negative side to the positive side, which would complete the circuit. But as soon as you put a, let's say, table salt in there, sodium chloride or any other salt for that matter, that's soluble, then it's going to dissociate and it's going to form ions in here. And once you've got some ions floating around in here, you'll have an opportunity for the electrons to be able to move through that solution, thereby completing the circuit and lighting up the light bulb. So taking a look at the diagram up top here, in this first box, we have a solution that doesn't contain any ions in it. So I've got my probes down in there, my electrodes down in there, and since there are no ions to complete the circuit, I'm not going to get my light bulb to light up. Now, if I put something into the water that's going to produce a few ions, a weak electrolyte, it will be formed, and I will get a little bit of electricity running through there And you can see that's at least lighting up a little bit. Now, if I put a good, strong electrolyte in there, like sodium chloride, it's going to form a lot of ions. And so if it forms a lot of ions, we're going to be able to transfer a lot more energy, and we're going to get a nice, bright light bulb. So what's the difference between something that's going to be a non-electrolyte, something that doesn't form any ions in solution, versus something that's going to be a weak electrolyte versus a strong electrolyte? So in the first place, let's talk about a non-electrolyte. Well, we said you have to have ions in solution to form an electrolytic solution. So any substance that doesn't form ions in solution is not going to be an electrolyte. For example, anything that is a molecular or covalently bonded compound, like table sugar, for example. Now, when we get to weak electrolytes versus strong electrolytes, we'll take a look at the next page. And we'll talk about the strong electrolytes first. So we have here that strong electrolytes are first of all going to be what we talked about so far, soluble salts. A salt is an ionic compound. If it's soluble, you put it into water, then the salt will dissociate, it will come apart and form its respective ions. Now we also have here under strong electrolytes, strong acids and strong bases. Remember what the definition of a strong acid is. It completely ionizes. So when we put HCl into water, it's going to be, because it's a strong acid, it is going to completely ionize, forming hydrogen ions and chloride ions. That's the definition of what a strong acid is. Same thing for a strong base. We know sodium hydroxide is a strong base. So we know that in water, it's going to completely dissociate, forming sodium ions and hydroxide ions. But now down to a weak electrolyte. This is acetic acid. And it has, right here, this hydrogen that, when in solution, will ionize to some extent. So what happens with acetic acid is that some of it comes apart, forming the acetate ion and hydrogen ions, but only a little bit of it comes apart, only a little bit of it dissociates, and an equilibrium forms. And so once that equilibrium forms, then what I have in my solution is all three of these species present. I have the acetic acid in there, I have some acetate ions in there, and I have some hydrogen ions in there. And that's actually the definition of a weak acid, is one that does not completely dissociate. And so since it produces relatively few ions compared to what it started out with, then it's going to produce a weak electrolyte.